Hi everyone. We now introduce Torres, EAM lead from Visualk. He will be sharing knowledge on 7 steps to predictive maintenance.
Good afternoon and good morning to everyone. Thank you for having us at the Lubrication and Reliability Virtual Summit for 2022. My name is Angel Torres. I lead the EM practice at Visualk. And today we're going to discuss our vision of the 7 steps to predictive maintenance. So with that, let me get started. So what are the 7 steps? So first one is to introduce reliability. Second one, to streamline routines. Third one, to plan cash flow. Fourth one, to predict the future. Fifth, to prioritize investments. Sixth, create and provide early warnings. And seventh, meet and maintain compliance. So let's start going through each one of them. As far as introducing the concepts of reliability, we think that the most important thing is to start with your asset records. And let's discuss what this entails. First and foremost, identifying your assets using an advanced EAM system. You should record the nameplate data. Where are they located? Things like creating a hierarchy so you can see how they can relate. Things like what site, within the site, which building, within the building, which floor, within the floor, which office, so on and so forth. Or you can look at it from a system, subsystem, asset, position, and components. Then, if you're able to do this, which we know it's kind of a challenge, right? To identify and associate the spare parts or the critical spare parts that are required to maintain these assets. If you can, identify and record warranties, associate documents, images, drawings, videos, PNIDs, etc. Associate the original specifications and the operating procedures for the asset, and record process control specifications. Also, if you can record video for critical work processes and attach it to them, or we have seen customers use YouTube videos, which there's plenty of them to go around, to basically instruct people and keep them fresh in terms of how to do their tasks. Now, the other component about the introduction of reliability is to understand the risk related to the asset, right? So the first part here is to make sure that you bring in all the stakeholders, meaning the operations, the environmental, health and safety, the maintenance, and other people, perhaps your finance group, right? Then assess the severity of the failure. I mean, what would be the damage to the equipment itself, to other assets? What would be the damage to the equipment only? And then assess the likelihood of failure, right? Whether it's something that could happen in the remote future, 20 plus years, right? Unlikely, 10 to 20 years, possible within 5 to 10 years, likely 1 to 5, and certain within the next year. And then calculate a risk index for your assets, whether it's catastrophic, undesirable, or unacceptable. Those are just a few examples of how you can calculate a risk index. Then moving on. The next step is to streamline the routine, and we propose to do so through standards, right? So your enterprise asset management system should be able to check for proper certifications and skills prior to assigning work. So that means that if we keep records of our employees or contractors, and we also keep records of the certifications that they're holding, and most importantly, if they're valid, then we can tie that to our work and make sure that we filter and we're able to assign the work to the people that have the correct credentials, right? Secondly, being able to capture and document all your asset interventions, all of the work that takes place, right? The other thing is to manage approvals and make sure that your records are secure. Um, that they can be deleted, or once work record has been closed, that no one can come in and change anything, right? And if they do, see if we can attach audit records to those, right? Um, Everything having to do with your decisions should be documented through your system, right? Any corrective or preventive action, also those decisions need to be documented, and try to capture and report all changes to the asset, right? Um, Document incidents, accidents, and emissions and their follow-up actions, and provide regulatory reporting, right? So also, if you have the ability to audit and keep track of changes, and who did the change, when it was done, that's also one of the things that will help. Now, the other approach is looking through the standards, is to use the past 55 approach for life cycle, right? So it's based on the plan, do, check, and act, right? So on the planning side, you're looking at your asset strategy, you're looking at the objectives, you're looking at what actions are required or necessary to get the results that you need. Then on the do side, right? Establish the enablers, right? So that you can actually implement an asset management system and other necessary requirements, and monitor and measure the results, right? So if it doesn't get measured, we're just practicing, right? And obviously, upon checking, take action, right? So it's a virtuous cycle, and it's all guided by past 55. Now, the other thing is on the third step is on planning your cash flow, right? So understanding high level flow to budget planning. So we started by looking at creating an asset registry, creating a hierarchy for your assets, assessing the condition strategy, evaluate that condition, and from there determine which assets are at risk, what is their within their asset life cycle, where are they, what is their residual life, and then also establish a level of service, right? And from there determine your capacity planning, and then from there begin defining budget scenarios, right? So you have all these different steps, and all these different stakeholders that come into play. But at the end, basically what we're saying is identify your assets, identify the condition, determine the likelihood of some of these assets failing, determine what is the residual life on the asset, and start planning from there, right? So it's not a finance only or accounting only exercise, but it's rather a team effort. Now, one of the things that we're seeing, right, is that when you're planning your cash flow, um, you have options in terms of to automate some elements of your operation, um, but not all things are created equal, and not all things will yield the same return, the same results, right? So the IoT Institute, they did a survey, and they look at the kind of upgrades that organizations were making in order to become digital and deploy industrial IoT projects, right? So they looked at things like connecting devices, new software, upgrading your machinery so that it can actually connect and communicate, right? Adding sensors, actually hiring new personnel, right? Things like adding real-time alerts, connecting plant information systems, simplifying and providing single views, pretty much like the concept of the McDonald's order system, right, where all the employees see in just one screen everything that's going on. Implementing smart technologies, right? So these are all different initiatives. However, as part of that survey, the participants, on average, they reported having productivity gains of 18%, meaning You're gonna have different returns for different initiatives, and there's information out there. You can dig down and see what makes the most sense for your organization. Now, then moving into predicting the future, right? So we're looking at things like using artificial intelligence to model complexity, right? So there are different platforms out there. The point is that through artificial intelligence, through machine learning modeling, um, you can take your information and put it to work, right? So you've been operating for 1 year, 5 years, 10 years. You've been recording data for 5 years, 10 years, 20 years. Now let's put that data through use, right? So by using things like artificial intelligence and machine learning, we can take your experience, your system data, and put it to good use, right? So the idea here is to be able to model the complexity through different tools, right? So this is just one example where we're creating models. We're taking that data, we are training our models, fine tuning our models, and then using that models to generate actions, right? And then retrain our models on a timely basis. Now, the other thing is, um, how do you prioritize your investments, right? So, what we look at is, under a state of good repair, a capital planning process. So, for example, first one, and I've mentioned this several times now, right? Create an asset inventory, um, classify it, create a hierarchy, put in the attributes, the expected life, replacement cost, risk, priority. These are the elements, right? Um, Identify your projects based on the condition of your assets. Identify what's the age, what's the risk, and then define a prioritization criteria, right? Look at what's service critical, what is the service quality, and from there you can start defining projects and prioritize the projects, right? So typically this is a process that a human will do, look through the data and try to come up with options. Engineering may come in and give recommendations as to what projects need to be done. But obviously, you have a limitation on capital, so you just can't do everything. You need to prioritize, right? Now, the fifth step has to do with being able to model, right? If we do this, what would be the result? What would be the impact? What would be the return on investment? And from there, you can develop a 5-year plan, capital investment plan, and it's a cycle, right? Year after year, you're gonna have to fine tune this as things arise. Now, one example, and this is taken from the Strategic Asset Management Plan for the Federal Columbia River Power System. This is something that to us was kind of mind blowing, right? And this is the way they look at their capital investment planning. Basically, those blue lines, bars at the beginning of the chart, they talk to the projects that they have identified and the projects that they have prioritized through this process. Now, as they walk down in time, what they're expecting is for asset analytics to basically give the recommendation. So there are engines out there that will look at the different scenarios and model the return, and from there help with the prioritization. So you're not alone. It's coming, right? But it's kind of the way we're looking at the future. Now, all of this is made possible by having condition assessments, being able to identify the actual condition of the assets, being able to predict the condition of that asset in the future, and then putting together your capital plans and using modeling tools to find out what gives you the best bang for your buck. Now, the other element, the other step is being able to create and provide early warning. So obviously, you cannot do it for all of your assets. So one way to go about it is to create an equipment ranking, right? and with that, being able to formulate questions that will help you assess your assets, right? So with that, you can do reliability rankings, you can do condition rankings, and all of these data will help you prioritize, what assets you should go for. And for example, bring data from your SCADA, from your control system, put boundaries in place and have the system monitor where is the asset performing. And when either approaching those limits, notify. Obviously, if it over exceeds the limits, then obviously notify and create a corrective action. So the tools are out there, right? And finally, um, when we said meet compliance every step of the way, right? Non-compliance is or can be very costly, right? It can also jeopardize safety or hurt your brand equity, right? So be alert, right? You're looking at building code compliance, OSHA, EPA mandates, workforce, public safety issues, processes, and industry certifications. So there are many variables, there are many sides to this coin. But the important piece is that you have the tools that will help you monitor all these different things and ensure compliance. So that's us for today. We thank you so very much. And I think we are going to open the floor for questions. So thank you.
Hi, Engel.
Hi, good morning.
Good morning. So there are two questions here. A question from Mr. Ahmad Mazhar Basir.
Okay. All
Yeah.
right. So the question is, can this PM be applied to a fleet of on highway trucks? A truck, be it on a highway or just parked down the street, it's an asset, right? An asset is an asset is an asset. So the answer is definitely yes. And obviously, there are different methodologies when it comes to vehicles. In the States, there's something called the Vehicle Repair uh, and Maintenance System, PRMS. Um, and basically, it's a way for you to code not only the vehicle and its components, but also the different failures that you may have on the vehicle and the repairs that are going to take place. So, yeah, definitely yes.
Okay.
Okay, so SGR refers to state of good repair. It's really coming, and I had to look it up just to make sure that I say it right. It's really an initiative launched by the Federal Transportation Authority in the U.S. Basically, what it's done is it establishes a framework for repair of, actually it's also related to vehicles, right? So it's coming for everything that moves in the US, trucks, rails, trains, all of these moving assets, and it establishes a framework for evaluating and then coding the different failures and the corrective actions. Should I read the next one? How long it takes to implement these 7 steps, starting from scratch? Actually, um, like any question regarding time, right? It depends. However, um, if you start from scratch and you have a good understanding of where you're going, and let's say that what I just presented is the absolute truth. Obviously, this is our take on it. But let's say that you use this as a guideline and you kind of define the destination. I think it's gonna be like way easier for you to start with the end in mind. whereas people that already have, their assets, have already been working on them for a while, have some kind of a system. um, Sometimes that becomes harder, right? Because you have to kind of like try to step back in time, and sometimes what we have found, for example, we did a pilot with a power plant. They wanted to do artificial intelligence to do predictive maintenance, and what we found is that the way in which they defined, we were working with a group of pumps. The way in which the pumps were defining the system really made it impossible for the artificial intelligence algorithm to make any sense of the failure history. You had these four pumps. Actually, you had six physical pumps rotating between four positions in time. So all of the data was taken at the position level, right? But they were not in any way attached to the actual pump, right? So as they moved from place to place, the history got completely distorted. So thank you for the question. I think that probably the most important takeaway from this is the fact that if you sit down, you plan, you look at it in the long term, and then you start the journey, but knowing kind of where you're headed, rather than to try to make amends as you go along the way. So hopefully, um, I, I can't say it's gonna take 1, 2, or 10 years. A lot of it depends on the effort, right? Because obviously you have a plan to run, you have a plan to maintain. So doing these kind of things becomes a bit of a challenge. One thing that we've seen, right? Interns. Get some engineering interns and get them to help you out in this kind of initiative.
Is there any other question?
Thank you.
If not, we are going to end this session. Thank you very much.
Well, have a great day. Thank you.
Thank you. Bye bye.